Hi everyone, this video is on question 3 of exercise 9H from Pure 2. So in this video, I'm going to do parts G, H, and I. So last time we talked about the implicit differentiation and how it works. So today we have more involved examples. And the first one is G, which is x minus 4 to the power of 4 is equal to x plus 5 plus 5. So when we want to differentiate this, we should be very careful when we have implicit differentiation, because it's very easy to get back to our usual differentiations when we didn't have a y term or dependent term, and we just differentiated them with just the usual way. Because here, for example, we have x minus y to the power of 4. So it's very easy to just use the usual way of differentiating and say, okay, so the derivative of inside, this is the channel, right? So the derivative of inside is just 1, and the power is 4, so that comes down, and we write down the bracket, and then also the power is minus 1. But there's a big problem with this one, because this is implicit differentiation. So we also need to differentiate the y term, and we can't just ignore that. So therefore this is wrong, and there is one more term which is related to the y term. Okay, so as usual, we can start by writing down the power 4 times, and we can also then write down the bracket, because the bracket doesn't change at first, and then the power minus 1, and now this times the derivative of inside, the derivative of the bracket. So inside the bracket we have basically two terms. One is the x term, the other one is the y term. So the derivative of x term is 1, and the derivative of y term is minus 1, but we always multiply that by dy dx, so it's going to be minus dy dx. This is the derivative of the left hand side. And as you can see, at first when I showed the usual differentiation, we missed the dy dx term. All right, and then right hand side is probably much more straightforward. So x differentiates to 1, y differentiates to dy dx, and 5 differentiates to 0. Now we need to rearrange this, because that's what the question is saying, to write dy dx in terms of x and y. So what we can do here is that we can expand the bracket on the left hand side, because at some point we need to take a factor of dy dx. So we can do 4 times x minus y cubed, so this is that times 1, and then again this term times dy dx is going to be 4 times x minus y cubed dy dx is equal to 1 plus dy dx. And now I want to have dy dx's on the left hand side and the other things on the right hand side. So minus 4 times x minus y cubed dy dx minus dy dx is equal to 1 minus 4 times x minus y cubed. Now we can take factor of dy dx, and we get minus 4 times x minus y cubed minus 1 is equal to 1 minus 4 times x minus y cubed. And finally, dy dx is equal to 1 minus 4 times x minus y cubed divided by minus 4 times x minus y cubed minus 1. So this is the answer, part A. And this question has specifically asked to rearrange this, but it's not the case all the time. And sometimes it's fine to just leave your answer in the same form as the first line. But again, it just depends on the question. Right, now we have e to the xy is equal to x e to the y. Again, it's implicit differentiation, and we actually need to use the product rule in this case, because in both sides we have two functions. We have e to the x times y, and here we have x times e to the y. So we need to use the product rule twice. On the left hand side, we can write down the first function times the derivative of the second function. The derivative of y is dy dx, plus the derivative of first function e to the x differentiates to e to the x times the second function, which is y, is equal to, again, the first function times the derivative of the second function. So e to the y differentiates to e to the y, but as always, we multiply that by dy dx because that's the dependent term. And the second part of the product rule says write down the derivative of the first function times the second function. So that's 1 times e to the y, which is just e to the y. Again, it's now some more algebra just to rearrange this. So e to the x dy dx minus x e to the y dy dx is equal to e to the y minus e to the xy, and taking a factor of dy dx gives e to the x minus x e to the y is equal to e to the y minus e to the xy, and dy dx is equal to e to the y minus e to the x y divided by e to the x minus x e to the y. And so this is the rearranged answer. Okay, and the last one, we have root xy plus x plus y squared. First of all, let's rewrite root xy as xy to the power of half. Then the rest of the terms are going to be the same. Okay. Again, another similar thing that we should be careful is again this chain rule that we have here. So it's different to the usual differentiations because we have x and y, and both of them basically are needed to be differentiated. So in this case, we can again begin by the easier part, which is writing down the power, then writing down the bracket with power minus 1, and then times the derivative of inside. So the derivative of inside can be found by using the product rule. Be careful, because we have x times y, so two functions. So the product rule says write down the first function times the derivative of the second function, y differentiates to dy dx. Now the derivative of the first function, which is 1 times y. Okay, now this entire thing is a derivative of x, a square root of xy, for instance, and that's how we can differentiate these kinds of things. So the next term is just x, so x differentiates to 1, and y squared differentiates to 2y times dy dx is equal to 0. Okay, now let's expand the bracket first. So we are going to get x over 2 times xy to the power of minus a half, and then this times, also it has a dy dx term, then this times y plus y over 2 xy to the power of minus a half, plus 1 plus 2y dy dx. Okay, we can now take factor of dy dx times x over 2 times xy to the power of minus a half plus 2y is equal to minus 1 minus y over 2 xy to the power of minus a half. And finally, dy dx is equal to minus 1 minus y over 2 x 5 to the power of minus a half over x over 2 xy to the power of minus a half plus 2y. So this one got so messy, but fortunately it's not always like this. Okay, so that's it for this video, and thank you for watching.